Alright, here we have our simulation for the turning experiment. You can see that we've got factors of speed, feed, depth of cut, the density of the material, which we're not going to change, the insert cost, the number of edges, and the tool life. Those are all part of the different tools that we have. So we've got a tool number 1, number 2, number 3, and number 4. We're going to choose 2 of these that we're going to study in this. And then there's the coolant cost, the coolant amount. Now, based on the tool, that's going to dictate insert cost, number of edges, and tool life. Labor cost and density of materials, those 2 things are going to be fixed. Alright, so from the physics, speed and feed and speed and depth of cut and feed and depth of cut, those probably all have combined effects. So we're going to want to be able to study 3 combined effects, and then we have 1, 2, 3, 4, 5, 6, 7 factors. Alright, so 7 factors and 3 combined effects. So what that's going to do is that's going to dictate that we're going to be using a 16-run fractional factorial design. Now, the task that we have now is to assign the factors to the proper columns. Now, when we go to run the experiment, we would set up the combinations based on low settings and high settings in our model, and we would put those settings in here, and then it's going to calculate the cost per pound of material removed. So we'll be able to use that for each experiment run. We'll have a cost per pound of material removed, and we'll be able to use that in our analysis of variance when we go to analyze the experiment. So that's how the simulator works. Now, we can choose any of the designs that we've provided to you, but the one I'm going to use is going to be this 16-run Yates algorithm. We could study up to 10 factors and up to 5 combined effects. Now, I usually print one of these out. I make a list of here's the variables that we're going to study. And we want to study the combined effect of feed and speed, speed and depth of cut, and then feed and depth of cut. So for those combined effects, I need to find one of the interactions that's going to have the ability to be a common between 2 combined effects, and then still have one more for this last one here. So if I come over to my groups, I have these 5 groups. I can select anywhere from 1 to 5 interactions, but no more than 1 from each group. So if I take a look at this, A and C has a possibility. So A for speed and C for feed. All right, and then what about depth of cut? Well, A and D. Now, do I have a C and a D? All right, not here, but I do have a C and D down here. So I can select to use columns A and C, A and D, and C and D. So that means I'm going to put speed is going to be over here in A, and then in C, I am going to put our feed rate, and then D is going to be depth of cut. All right, so now what am I going to do with B or E, F, G, and I still have these other ones. So we're going to have A, C, D. Now if I look at some of these other combined effects that I don't want to be messing around with, all right, I'm probably going to want to skip E, F, and G and B. Now what I'm going to do is I'm going to make these all unused columns. So I'll call those unused. So when I go into the software package, it's going to present me with this, and then I'm just going to assign a bogus thing to each of these, and they'll get combined into the unexplained once we run the experiment. Alright, so now I know I can study the AC, AD, CD combined effects. I've got these main effects placed with their interactions. That's what we always do first. And then what I can go ahead is, okay, where am I going to put the cooling quantity? Okay, so I'm going to put the coolant quantity here. I'm going to put the coolant cost in I, and then I'm going to put the tool in J. So now I have assigned my factors to the appropriate columns in the design, and now when I go into Minitab or Jump or Sigma XL, I can select this 16 run experiment, and this is the design standard order. So it's going to come out in this order, but now we know where we're going to put the factors, and we know the interactions that we're going to be studying. So now we're ready to put this into Minitab and then design it. Once it's designed, obviously we've got to set our low and our high settings for each of these. And then once we generate the design, then we'll be able to come in and put the data settings into our simulator, and then it will calculate the cost per pound of material removed, which will then give us the data that we need so we can do our analysis. So let's get started with that in just a couple of seconds.